Beyond our solar system, astronomers have discovered worlds unlike anything found around the Sun. Among the strangest of these discoveries is the idea of a planet, made largely from diamond.n (BunMCCHun). These exotic worlds may form in star systems, rich in carbon. When planets grow in environments where carbon is abundant, their chemistry can become very unusual. Instead of the familiar rocks found on Earth, these planets may contain vast amounts of carbon minerals. During planetary formation, gravity compresses material deep inside the young world. Over millions of years, pressure and heat transform the interior layers of the planet. Under extreme pressure, carbon atoms can crystallize into diamond. These processes may create enormous diamond-rich layers beneath the planet's surface. Some scientists believe certain super-Earth planets could contain vast diamond interiors. Astronomers study these worlds by measuring their size and mass. These measurements help scientists estimate the planet's density. Unusual densities can hint at exotic internal compositions. Observations of distant stars sometimes reveal planets with unexpected chemical signatures. One famous example is the exoplanet known as 55 Cancri e. This super-Earth may contain large amounts of carbon deep inside its structure. If the conditions are right, much of that carbon could exist as diamond. Such a planet would be unlike any world in our solar system. Its interior might contain enormous regions of crystalline diamond. In the vast universe, entire planets made largely of diamond may truly exist. One of the most fascinating candidates for a diamond planet is the exoplanet known as 55 Cancri e. This super-Earth orbits extremely close to its parent star. Because of this proximity, its surface experiences intense heat and radiation. Temperatures on the planet may reach thousands of degrees. Such extreme conditions can melt large portions of the planetary surface. Scientists believe oceans of molten rock may exist on this world. Above these lava seas, thick clouds of mineral vapor may fill the atmosphere. But the most unusual features may lie deep beneath the surface. Inside the planet, enormous pressure compresses material toward the core. Carbon-rich minerals may be transformed into crystalline diamond structures. Over billions of years, vast diamond layers could form within the interior. These layers might extend thousands of kilometers beneath the crust. On the surface, volcanic activity may constantly reshape the landscape. Lava flows and mineral deposits could create strange alien terrain. Crystalline formations might reflect the intense light of the nearby star. Astronomers cannot see these interiors directly from Earth. Instead, they study the planet using telescopes and advanced measurements. By measuring mass, size, and orbital motion, scientists estimate the planet's composition. These clues suggest that some exoplanets may contain enormous quantities of carbon. And under the right conditions, entire planets could hold vast reservoirs of diamond. Deep inside a carbon-rich planet, conditions become far more extreme than anything on the surface. As depth increases, pressure and temperature rise dramatically. These forces compress the planet's interior layers with enormous intensity. Carbon atoms trapped within these layers begin to change their structure. Under extreme pressure, carbon can transform into crystalline diamond. Over long periods of time, this process may create vast regions of diamond within the planet. These diamond layers could extend thousands of kilometers beneath the crust. The immense gravity of a super-Earth helps maintain these extreme pressures. Deep inside, the planet's interior may glow faintly with heat from the core. Heat slowly moves outward through layers of dense crystalline material. Compared with Earth's rocky mantle, these interiors may be very different. Instead of silicate minerals, carbon-based materials could dominate the structure. Scientists use computer simulations to explore these exotic planetary interiors. Supercomputer models help estimate how carbon behaves under extreme pressure. These models suggest that diamond-rich layers could be surprisingly common in carbon worlds. Such planets might contain more diamond than exists anywhere on Earth. However, these treasures would lie far beyond the reach of human exploration. Hidden deep beneath crushing gravity and extreme temperatures. These distant worlds remind us how diverse planets in the universe can be. Some planets may hide enormous diamond interiors beneath their mysterious surfaces. If diamond planets truly exist, their surfaces could appear unlike any world in our solar system. Instead of familiar rock and soil, vast crystalline structures might dominate the landscape. Mountains of reflective carbon crystals could stretch across the horizon. Under distant starlight, the entire planet might sparkle faintly in space. Some regions could contain enormous solid diamond formations rising from the crust. These structures would form over billions of years under extreme planetary conditions. However, reaching such treasures would be nearly impossible. Heat-crushing gravity and intense temperatures of super-Earth planets would make exploration extremely dangerous. Any spacecraft approaching the surface would face powerful radiation from the nearby star. Despite these challenges, astronomers continue to study these worlds from afar. Space telescopes measure the tiny changes in starlight as planets orbit their stars. These observations allow scientists to estimate a planet's mass, size, and density. From this data, researchers can infer the possible composition of distant planets. Some measurements suggest planets with unusually high carbon content. These clues hint that diamond-rich interiors may not be rare in the universe. Entire classes of planets may form in carbon-dominated star systems. Each new discovery expands our understanding of how planets can form. The universe continues to reveal worlds more exotic than we once imagined. Among them may be planets where diamond exists on a planetary scale. In the vast cosmos, even a world made largely of diamond could be real.